Welcome to November 9th LeetCode Challenge, Online Stock Span. Design an algorithm that collects daily price quotes from some stock and return the span of that stock's price for the current day. The span of the stock's price today is defined as the maximum number of consecutive days starting from today and going backwards, for which the stock price is less than or equal to today's price. So for example, if you have the price stock over the next 7 days for 10, 80, 60, 70, 60, 75, 85, then the stock span would be 1, 1, 1, 2, 1, 6, 4, 6. I'll go over the example in a bit. So I'll implement stock spanner class, which the class stock spanner initializes the object of the class. We have a method here that takes in the integer price and returns the integer where the span of the stock's price given by today's price is price. So let's go over our example here. So we initialize stock spanner and we call next on it a couple times, and we're using this example for the next 7 days. So say we initialize it, which is null, of course. So say call next on 100, which returns 1. Call next on 80, which returns 1. So notice how the values are decreasing. We call next on 60, which returns 1. Call next on 70, which returns 2, because the previous one before that is less than or equal to today's price, so return 2. And then we call next on 60. Then we call next on 75, which returns 4, because the last 4 prices, including today's date of 75, were less than or equal to today's price. And then we call next on 85, which returns 6, because the last 6 prices, I should say, were less than or equal to today's price. Right, which is less, 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 less. So all these are less, so therefore 6, including itself. So it constrains the prices between 1 to 10 to the 5, and at most 10 to the 4 calls made to next. So thinking about this approach, say if we were to use a brute force approach to keep all the keep an array of all the stock prices, then iterate through them backwards and then call next until you find the next price is greater than the current price, that's a good idea. However, there's a problem with the brute force approach where we're potentially looping over the same elements many times, so we don't want to do that. A good approach would be using a monotonic stack. So basically, for each price, we want to find today's price that's greater than the price given, and then that's pretty much the idea. So we use a monotonic stack. It's a stack where the elements are always sorted. So the stack can be monotonically increasing, which is sorted in ascending order, or monotonically decreasing, sorted in descending order. So say we have a monotonically decreasing stack, then we want to push a value, say x, then all elements less than x are popped up first to maintain the sort property. So we use that for our advantage in the future days, right? So let's see how we can implement the monotonically decreasing stack. So the first thing we need to do is initialize it. So initialize the stack. And the stack will store the elements in the format of price and answer in the monotonically decreasing manner. So let's say self.stack, and it's going to be an empty one. So far, so good. Next thing we want to do is initialize the answer to 1. And then the top of the stack has a format where we basically store the price and the answer, right? Or the top price and the top answer currently. So what we do is we have to iterate through a while loop where we have to find the self.stack exists and self.stack the last element, 0th index, so that we know that the top price is less than or equal to the price. Alright? So when that condition occurs, then we want to basically update our answer, and our answer is going to be updated with the previous values that were less than or equal to today's price. meaning that we have to pop from the stack. So it'll be stack dot pop, and we want to pop one element. All right. Beyond that, we always, what we call next, we always want to be able to append. So append our answer to the stack, and we're going to append the following price and our current solution. And then we want to return our answer at the end of all this. Alright. This should work because I ran it before. Alright, accepted. So this is basically using a monotonically decreasing stack to basically store our answer and then pop it off as we go along. So complexity analysis wise, we have, so say that we've given n number of calls to this next, even though we loop through, so it'll be actually constant time complexity, because even though the loop, we loop through, use a while loop for next, the while loop can only be run n times total across the entire algorithm, meaning that each element can only be popped off the stack once, and there are up to n elements. So basically this is using amortized analysis, where you take advantage of the time it takes to run next, the method next, to run across n calls, so it works out to be constant time, which is kind of cool. Space complexity, since we're using a stack, the worst case scenario for the space, since the stock prices are decreasing, while the loop never runs, meaning that we will take the stack will grow to n size, because we never pop it from the stack. And that is all. Have a great day, everyone.